In our last video, we looked at how to simplify composite trig functions when the inverse trig was on the inside of the parentheses. This time we have the reverse, where our inverse trig is on the outside and the regular sine or cosine is on the inside. So these ones are slightly more complicated only because it's not always as simple as just canceling things out or saying our answer is undefined. So let's take a look at how these will work. The first question is always the same question, and that's is our x value in the domain of the cosine or sine function or whatever. And so to do this, I'm going to again be referring to this chart, so hopefully you have this handy. This time, since sine, cosine, and tangent are the inside, these are the restricted domains that we're going to be taking a look at. So we want to know, is our x value in that domain? Okay, so first up I have 5 pi over 8 for a cosine. Well, according to that chart, the domain of the cosine function, our restricted domain, was between 0 and pi. And so I want to know, is that value in there? And yes, it is. And if you're not sure, then make it into a decimal. 5 over 8 is less than 1 pi, so it's in there. When it is in the domain, these are the really easy ones. Just like before, the inverse cosine of the cosine will cancel out. And so my answer is just what was or what my x value was. So 5 pi over 8 is the angle that we're looking for. So again, when you're in the domain, it's really easy. It's just a matter of canceling things out. It's when you're not in the domain that things get a little trickier. So let's take a look at these next two, which, spoiler alert, it's not going to be in our domain. So this time we're working with sine on the inside. So 10 pi over 9 is what I want to check. Well, according to that chart, which again hopefully you have handy, the restricted domain of the sine function is going to be between negative pi over 2 and positive pi over 2. In other words, negative 0.5 pi and positive 0.5 pi. And 10 over 9 is not in there. Again, if you want to check that, making it into a decimal, 10 over 9 is bigger than 1. It's not going to fit in between there. So I have a little bit of work to do. They're not just going to cancel out, and the answer is not undefined. I can still find an answer for these, even if it's not in our restricted domain. When the inverse was on the inside, in the last video, it was just undefined because we couldn't get out of that domain. This domain we can actually kind of work around. So here's what we'll need to do. First thing is I want to sketch this angle. So way back at the beginning of this our study of trigonometry, we sketched these angles. 10 pi over 9 is a little bit bigger than 1 pi, which recall 1 pi was down here, but it's not quite 3 pi over 2 or 1/2 pi. If you need to use decimals, that's fine. 10 pi over 9 is going to get you somewhere though here in quadrant number 3. So measuring around counterclockwise, that's my 10 pi over 9 angle. What I really care about though is just the reference angle, like we've always cared about. So I want to figure out how much past 1 have I gone to get down here. Well, I could do a little subtraction. I can do 10 pi over 9. If you're really good with fractions and get what's going on here, you can probably do this in your head. This little angle right here is going to be just pi over 9 though. I'm just 1 pi over 9 past the 1 mark. So that's my reference angle. Now this is somehow going to be involved in my answer. It's not necessarily your answer itself, but it's somehow involved in our answer. Here's what I need to do to finish this out. I need to figure out whether sine is positive or negative in this quadrant using this old trick, the ASTC thing. So this t told me that tangent is positive in this quadrant, but anything else is going to be negative. So I'm working with sine this time, so I know that my sine, S-I-G-N, is going to have a negative sine, or my sine, S-I-N-E, is going to have a negative S-I-G-N sine. Anyway, so here's how I finish this. Don't you love these problems? My angle is negative, but when I'm working with inverse sine, because that's the goal this time, I only have these two quadrants to pick from. Again, remember this chart back here. This bottom part, the circle, inverse sine, I can only pick from these two quadrants. So since we already determined we're looking for a negative answer, I need to redraw my angle in this quadrant down here. So to finish this, oops, let me find my problem again. To finish this, I need to take that pi over 9 angle and draw it in this quadrant, because sine is also negative in this quadrant. Well, drawing my pi over 9 angle here and rotating clockwise means I have a negative angle, so after all this work, my final answer is just going to be negative pi over 9. Well, I would definitely verify this using a calculator. These are really easy to double check, and you should, because they do get a little complicated. Just type in your original problem. Type in the inverse sine of 10 pi over 9, and you'll see you don't get 10 pi over 9. You don't even get positive pi over 9. Instead, you get negative pi over 9 because of our restrictions. Okay, so as I said, these get a lot more complicated than just saying the answer is undefined, like we had in the previous video. Okay, if you still have questions, let's try one more. If you got it, then you might want to try this one on your own. All right, first question is this in my domain for tangent? Recall that our domain for tangent, our restricted domain, was between negative pi over 2 and positive pi over 2. Or in other words, negative 0.5 pi and positive 0.5 pi. And unfortunately, 3/4 is equal to 0.75. So that's not going to fit in between there. So we do have a little more work to do for this problem. We can't just cancel these things out. All right, so let's go ahead and take a look at how this will work. First step is graph your angle. Well, the negative angle tells you to rotate clockwise. And down here, this would be negative 0.5 pi or negative half pi. This would be negative 1 pi. So I'm somewhere in between there. So once again, I'm somewhere in quadrant 3. So that's my negative 3 pi over 4 angle. I need the reference angle, though. So I need this missing piece right here. Well, what do I need to do to get from 3/4 pi to a solid full 1? Well, I need to add 1/4 pi onto that. So my reference angle is pi over 4. Now, somehow that will be involved in my answer, whether it's positive or negative or something else, but somehow that will be involved in my final answer. So I got to figure out what kind of angle I'm looking at down here. Well, ASTC tells me that tangent is positive in this quadrant. So I need another quadrant where tangent is positive. And once again, recall, using this piece of paper over here, that tangent can only exist in these, or inverse tangent can only exist in these two quadrants. Since I'm looking for where it's positive, I must be looking for quadrant 1. So to finish this problem, let's take our pi over 4, redraw that in quadrant 1, and since I'm now measuring counterclockwise again, I do just keep the sign the same. My final answer comes out to be just positive pi over 4.